Welcome to our favorite YouTube channel DCD Electrical Knowledge. Today's goal is to learn electrical measuring instruments, the master study guide. The master classification of instruments. Electrical instruments are basically two types: absolute and secondary. Absolute instrument gives value in terms of constant, lab use only, that is transient galvanometer. Secondly, secondary instrument. 99% of what we study and use. Secondary instruments are further classified as indicating instruments, integrating instrument, and a recording instrument. That is, secondary instruments are three types. Indicating instrument shows value right. Now, example is ammeters and voltmeters. Integrating instrument adds it all up over time. That is kWh meters, that is kilowatt hour meter or energy meter. Thirdly, recording instruments draws a graph on paper, likely ECG, etc. Reading the dial. The secret code as per table number 1, type of meter symbols. Moving coil instrument and moving iron instrument are symbolically represented in table number 1. Table number 2, current symbols is represented in the table, likely a straight line DC only, a sinusoidal wave AC only, a straight line and sinusoidal wave represents AC and DC, and lastly the symbol like U is represented horizontally. Table number 3, using position symbol. T used for vertically and U like this symbol used horizontally. wrong position is equal to error in reading. Correct polarity matters for moving coil instrument. The anatomy of a reading. The three essential forces. The hidden battle inside every meter. Controlling torque TC. The stop force fight TD ensures the pointer stops at the exact right value and returns pointer to 0 when power is off. It is denoted by TC, that is controlling torque. Then deflecting torque, denoted by TD. The go force caused by the electric currents, magnetic or a heating effect, moves pointer from 0, and damping torque TB. The steady force kills the wobble or vibration or oscillation, so we can actually read the reading. The key equation at steady state reading, TD is equal to TC, that is deflecting torque is equal to controlling torque. Controlling force match up gravity versus spring. Controls are two types: gravity control and spring control. Gravity control figure shows the arrangement for the gravity control of an instrument. It is cheap and durable, no temperature errors, must be used strictly in a vertical position. Spring control figure shows the constructional arrangement of spring control. The spring is made of phosphor bronze, low magnetic and low resistance. Can be used in any position. Springs also help carry current into the coil. Damping force, killing the wobble, the final piece of the puzzle. The graphical representation shows along x axis time and pointer deflection along y axis. One represents under damped waste of time. Two represent critically damped, that is perfection. Also shows the correct reading target. Without damping, the inertia of the moving system makes the pointer oscillate or vibrate. Damping brings it to rest instantly. So, damping system is urgently required in an instrument. How to dampen friction versus magnets? Dampings are mainly two types: air friction damping and eddy current damping. Air friction damping shows the figure. As the pointer moves, the piston of this damping arrangement compresses air. The air pushes back, creating friction to slow the wobble. The eddy current damping. This figure shows the arrangement of eddy current damping. Magnetic magic disc cuts flux, induces eddy currents. Lenz's law creates an opposing force. The most efficient damping method is the eddy current damping. Deep dive PMMC anatomy, that is permanent magnet moving coil. Figure shows the constructional view of PMMC. Let us study the various parts of permanent magnet moving coil instrument. The U-shaped permanent magnet made of alnico provides the constant magnetic field. Soft iron core, fixed inside the coil and makes flux uniform and radial. Rectangular moving coil, fine insulated copper wire. Spindle and jewel bearing, low friction pivot. Springs, two phosphor bronze springs provide controlling torque and lead current in or out. The former, the aluminium former, is not just a frame, but it produces the eddy current damping. Two spring phosphor bronze springs provide controlling torque and lead the current in or out. Spindle and jewel bearing, low friction pivot. The physics of PMMC. The T is equal to BLIN equations. TD is deflecting torque is equal to B, means flux density in air gap, L, length of the coil side, I, the current passing through the coil. The only variable, everything else is constant. N, number of turns, because B, L, and N are fixed constants. Deflecting torque TD is directly proportional to the current. That is, TD is proportional to I. This is the physics of PMMC, that is, permanent magnet moving coil instrument. Visualizing the math, the scale type, uniform scale, because TD varies I. The pointer moves the exact same distance for every ampere, easy to read. On the other hand, camped or non-linear or uniform, that is non-uniform scale, happens when TD varies I square. Harder to read at low end. PMMC, the report card. Advantages: consumes very little power, uniform, easy to read scale, high torque to weight ratio, less friction error, highly efficient eddy current damping, and no hysteresis loss. Disadvantages: DC only, will not deflect on AC supply. Very delicate construction, high cost compared to moving iron instrument. Magnetism can weaken over time. That is aging error. Moving iron MI instruments. The AC and DC workhorse. Moving iron instruments are two types: attraction type and a repulsion type. Attraction type: magnetic field pulls the unmagnetized iron inside the coil, that is TD varies I square. Repulsion type: both vanes get magnetized with the same polarity by the coil. Like poles repels, pushing the pointer, that is TD varies I square. Because it relies on induced magnetism, which flips when current flips. MI meters works on both AC and DC. The ultimate showdown: PMMC versus moving iron. Supply type: PMMC, DC only; MI type, AC and DC. Scale: PMMC, uniform and cramped, that is non uniform for MI type. Controlling force: for PMMC, spring control, and gravity or spring for MI type instrument. Damping method: for PMMC, eddy current, the best, and air friction for moving iron instrument. Cost and build: PMMC expensive and delicate, MI cheap or robust. Accuracy: high for PMMC and moderate, there is hysteresis error for MI. Memorized this table for guaranteed exam marks. electrodynamometer, the wattmeter king, creates the magnetic field moving coil attached to the pointer. How to fix the PMMC so it works on AC? Replace the permanent magnet with an electromagnet since both the fixed coil field and the moving coil current reverse. At the same time on AC, the torque stays positive. Primary use as high accurate wattmeter for measuring power. The synthesis: one page exam cheat sheet indicating instrument PMMC, damping eddy current, scale uniform, uses DC, voltage and current only. Moving iron, damping, air friction, scale cramped, uses AC oblique DC, voltage and current. Electrodynamometer, damping, air friction, uses AC oblique DC power, likely wattmeter. Three forces: deflecting, moving it, controlling, spring or gravity stops it, and damping kills wobble. Good luck. No more today. Next, we meet you in next videos. Please like, share and subscribe my channel DCD Electrical Knowledge. Thank you.